Hello my dear friends and students. Welcome to today's session where we have to see the back EMF and voltage equation of DC motor. In previous sessions we have seen the detailed construction and operating principle of DC generator as well as DC motor. Now we have to discuss about the back EMF which is present in DC motors, also its significance, its importance in DC motor, and we have to derive the voltage equation for the DC motor also. So what is mean by back EMF? So EMF electromotive force, we know that whenever motoring action takes place, or as per the working principle of DC motor, whenever a current carrying conductor is placed in a magnetic field, it feels a force and it starts rotating. If this is a working principle of DC motor, then working principle of DC generator says that if there is a relative motion between magnetic flux and conductor, EMF gets induced in that conductor. So when motoring action takes place, inside that motoring at the another end, generating action is also takes place. When motoring action takes place, when rotation starts, then conductor when starts rotating, it also cuts the magnetic flux lines. So EMF can be induced in that conductors. Now this EMF is induced as per the generating action, but it will oppose or it will act opposite to the supply voltage. That's why it is called back EMF. That's why it is called back EMF. When the armature winding of DC supply or DC motor starts rotating in the magnetic flux produced by the field winding, it cuts the line of magnetic fluxes. Hence, according to Faraday's law of electromagnetic induction, there will be an induced EMF in armature winding. As per the Lenz's law, this induced EMF acts in opposite direction to the armature supply. That's why it is called back EMF. But the value of back EMF will be given by the same formula which is used for the EMF, generated EMF in generator, that is nothing but P phi NZ upon 60A. Only here we use the suffix B, that is for back EMF we are using EB, and the formula will be same, P phi NZ upon 60A, where P is nothing but the number of poles, phi is nothing but the flux produced by each pole, N is nothing but the speed of armature or the motor, and Z is nothing but the total number of conductors placed in the armature tooth, and A is nothing but the number of parallel paths. Depend upon lap winding and wave winding, the value of A can be equal to P or equal to 2 depending upon the type of winding we are using. So this is all about the back EMF. Now we'll see or we'll discuss what is the significance or importance of this back EMF in DC motor. Though it works in the opposite of supply voltage, it have its own significance. Now we'll discuss on that. The presence of this back EMF makes DC motor a self-regulating machine. How? That we'll discuss. It makes the motor to draw as much armature current as is just sufficient to develop the torque required by the load. When the motor is running on no load condition, small torque is required to overcome the friction and windage losses. Therefore, in this case, armature current IA is required a small, and the back EMF is nearly equal to applied voltage. If the motor is suddenly loaded, the first effect is to cause the armature to slow down. Therefore, the speed at which the armature conductor moves through the field is reduced, and hence the back EMF EB also reduced. The decreased back EMF allows a larger current to flow through the armature, and a large current means increase or large this large current means increased driving torque. Thus the driving torque increases as the motor slows down. The motor will stop slowing down when the armature current is just sufficient to produce the increased torque required by the load. and in opposite side, if the load on the motor is suddenly decreases, the driving torque is momentarily in excess of the requirement, so that armature is accelerated. As the armature speed increases, the back EMF EB also increases and causes the armature current IA to decrease. The motor will stop accelerating when the armature current is just sufficient to produce the reduced torque required by the load. It follows, therefore, the back EMF in a DC motor regulates the flow of armature current. That's why it automatically changes the armature current to meet the load requirement. Hence, this back EMF, though it will act in the opposite to the supply voltage, it plays an important role when load on the motor increases or decreases. Accordingly, it will create or it will give the armature current value either higher side or lower side. So it will automatically manage the value of IA. So this is all about the back EMF and its significance. Now we'll discuss the voltage equation of DC motor. Here is the symbolic representation or equivalent circuit of DC motor, where back EMF EB is definitely opposing to this or it is opposite to the supply voltage V. RA is nothing but the armature resistance, IA is nothing but the armature current, and V is nothing but the supply voltage. Now we have to derive the voltage equation as from the equivalent circuit diagram. The armature supply voltage V has to overcome the opposition posed by the back EMF EB and some other voltage drop such as brush drop and the voltage drop across armature resistance. So from figure we can write that voltage equation V is equal to EB plus IA into RA plus V brush. EB is nothing but the generating voltage because of generating action. IA into RA is nothing but the voltage drop in the armature, and V brush. Generally, these V brushes are considered across the brushes. This voltage drop is considered negligible. So, in general, we can write this voltage equation: V is equal to EB plus IA into RA. So this is all about voltage equation of DC motor. So in today's session we have discussed the back EMF, what is meant by back EMF, why it is called back EMF, and what are its significance. After that we have seen the voltage equation of DC motor, that is nothing but V is equal to EB plus IA RA. I hope you are getting these two concepts. So thank you all.